All right, I'm going to go ahead and walk through one problem from each section just to make sure there's no confusion on how to do any of the problems with what the directions are asking. So first section, write the locator point. So the locator point here would be +4, -2. Write the locator point in transformations. So the transformations, right 4, down 2. Next section just asks you to graph. These ones are kind of funky, so I wanted to do one of the ones that had an inequality. So first I'm going to look for the locator point. That would be +1, +5. So to the right 1 and up 5. And then I'm going to go ahead and plug that into Desmos and get the rest of the points so that I can graph them. So I'm going to do y equals. Notice that even though it's an inequality, I'm typing an equal sign because Desmos will not give you the points if it's not an equal sign. So now I'm going to type SQRT, get my square root. I get the +5 on the end. Okay, so I'm going to get my list, get my table. This is a good sign whenever you have a square root graph to be able to see some of the undefined points. That means that you have the points that are to the left that are off the graph. Here's 1, 5. That's the start of the graph. And so now I'm going to press enter. I'm going to get these other points over here. I'm ignoring those decimals. Oh, I went way too far. 17. I can't graph that. But I can graph the other points that I got. So 1, 5, 2, 4, 5, 3. There's 2, 4, 5, 3. I know you can't see it. I'm going to show you guys in a second, but you can graph along with me. 10, 2 looks like the last one that I'm going to be able to graph. Oops. And I'm not drawing the graph yet because I know this is an inequality, but I'm just graphing the points so far. So that's what my points look like. And then once you have your points in, you can go back and you can put your inequality symbol into Desmos. And then we can see if the line should be solid or if it should be dotted and where the shading should be. And of course, you could figure that out yourself, but it's nice when Desmos will do it for you. So I'm going to hit the greater than sign, which is the same as the period key on your keyboard. So shift and then the period key. And then this is the part that's kind of interesting. We've never seen one like this before, where the shading doesn't go anywhere past to the left of an X value of -1, because that's where all the undefined values were. So we can't shade over there. So I'm going to do a dotted line. You can see there's a dotted line. So I'm going to make this dotted. And then there's going to be no shading over here. Was the shading above, I think? Yeah, the shading was above. So I'm going to shade above, but I'm not going to shade anything to the left. Just here. So that's kind of interesting about square root graphs, but Desmos does it correctly. So whatever you see Desmos do, you can do the same thing as well. Okay. All right. For the next section, it says to find the domain and range and the intercepts. So this is a negative square root graph, and those we saw on the previous page, they just kind of go down like this instead of going up. And so for domain, we're going to do from the left to the right. The left is going to be the locator point. So I'm going to write the locator point here. It's +4, +2. So from the left to the right, I'm going to use 4, 4, and then the right is infinity. So 4 to infinity. Infinity gets a parenthesis. 4 is going to get a bracket. For the range, we're going to go from down to up. Down is a negative infinity, and then up is going to be the locator point. So that's a 2. So I'm going to go from down to up. And I know that's kind of weird because when we did left to right, we used this part and then this part. And then when we did the range, we used this part and this part. And it's because you always do the smaller number to the bigger number. So with the domain, you always go left to right. With the range, you always go down to up. And so we did write it correctly. So parentheses there, bracket there. Now to do the x-intercept and the y-intercept, we are going to have to type this into Desmos. So I'll go ahead and do that. So I've got negative sqrt x minus 4 plus 2. So it looks like there is no y-intercept. That graph doesn't go far enough to the left to even touch the y-axis, but there is an x-intercept at 8. So I'm going to write 8, 0 for the x-intercept, and then I'm going to say none for the y-intercept. Okay. Next section says increasing and decreasing intervals. We have another graph that has a negative in the front, so it's going to kind of swoop down like this. And so we know that the increasing and decreasing intervals are always based on x values. So I need to know what my locator point is. It's -2, 6. And so the x value is right here, -2. And that's where the stick figure starts walking, and he is walking downhill. So this is decreasing. And he decreases to a right arrow, which is an infinity. So for increasing, I'm going to say none. For decreasing, I'm going to say -2 to infinity. Infinity can never be included. -2 here, when he starts walking, he's decreasing right here at the point as he's walking there. If you want to put parentheses for all of your increasing and decreasing intervals for every single time you answer one of those questions in this class, that is totally fine. I'll give you full points every time. Let's go ahead and plug that in and get the x and the y intercepts. So grabbing Desmos, gonna type y equals 1/3, -1/3, -1/3, sqrt, x plus 2 plus 6. All right, there's the y-intercept. That's pretty easy to find. That x-intercept is going to be kind of a doozy because I can see it goes off to the right quite a bit. So I'm going to write this y-intercept down. And now I'm going to go hunting for that x-intercept. Okay, I'm going to zoom out. Oh, goodness gracious. Oh my gosh, that's really far over there. Maybe, did I find it? Oh, there it is. 322. 322. How obnoxious. Okay, so this is what I've got for my answer. All right. Next one, use Desmos to find the locator point and the end behavior. We've got another one with a negative in front of it. So it looks kind of like this. So the locator point, this one doesn't have a number underneath the radical. So if you want to rewrite it so you can see it with a number there, it would be -3 square root x plus 0, or you could put -0. It doesn't really matter with a 0. And then a 6 on the end. So the locator point would be 0, 6. 0, 6. Because -0 would be funny. You know, it'd be weird. All right. If we look at the left, there's no arrow there. Remember, no arrow. So we're going to say undefined. What's the left arrow doing? I don't know. There isn't one. What is the right arrow doing? The right arrow is pointing down. So -infinity. Okay. Next set. Max or min. So this is a positive square root graph. And remember, positive square root graphs kind of look like this. No mountaintops, no valleys. So no max, no min. Can I trace the whole graph without picking up my finger? Yep. Okay. Next questions, find the domain and range and the end behavior. So here is a positive version of the graph. So it's going to look like that. This one says square root of x. And so if we want to rewrite that, that would be x plus 0 minus 5. And so the locator point here, if we wrote it, would be 0, negative 5. So if I'm going to go from left to right, the left part would be the locator point. It would be the x coordinate of the locator point. And the right side would be the arrow at infinity. So my domain is 0 to infinity with a bracket around 0. The range, draw this again, would be from down to up. The down part would be the y coordinate. And then the up part would be an infinity. So from down to up. Again, these are both brackets because I can put my finger on that point when I look at it. When I look at the left arrow, when I look at the right arrow, what are they doing? Well, there is no left arrow. These graphs stop suddenly. So the left arrow is undefined. It's just not there. The right arrow points up. So that would be positive infinity. Okay. And then the last section here has a negative. So the picture is going to be like this. I'm going to need my locator point. So positive 4, negative 2. Increasing and decreasing intervals are based off of x values. So I'm going to use the x value of the locator point. This is a right arrow. So I'm going to use a positive infinity for a right arrow. And then if my little stick figure is walking, he's walking downhill. So increasing is none. Decreasing is 4 to infinity. If I look at my stick figure, if he's standing right here, is this part of the downhill answer? And the answer is yes, it is part of it. So I'm going to put a bracket there. But if you want to always put parentheses for increasing and decreasing, that is fine. As I look at the left arrow, is it pointing up or down? It's not pointing anywhere because there's no arrow there. So undefined. As I look at the right arrow, which direction is it pointing? Is it pointing up or down? It is pointing down. And there you have it. All the different ways you can do those problems.